Hi, and welcome back to first year microeconomics. We've done demand, we've shown supply. Now in this presentation we put them together so that we can start predicting what the price of apples will be. I'm going to start by giving you a very general definition of what economists call an equilibrium. From an economic perspective, an economic system is in equilibrium when, given their individual choices and options, each person can achieve his or her planned outcomes and no one wants to change his or her plans. This is sometimes referred to as a Nash equilibrium, after the Nobel Prize winning economist John Nash. We know that an individual demand curve captures the plans of an individual buyer in the market. And we know that the market demand curve captures the aggregate plans of all the buyers in the market. So clearly a demand curve is going to be a critical element when looking for our market equilibrium. So let's start by drawing our market demand curve for apples. Let's suppose that if the price of apples is $9 per kilogram, then in total people would like to buy 7,000 kilograms of apples per day. So this point up here is a point on our market demand curve for apples. And suppose that if the price is $6 per kilogram, then in total people would like to buy 9,500 kilograms of apples per day. So that means that we have a second point on our market demand curve up here. And then let's draw one more point. Suppose that the price of apples is $4 per kilogram, then in total people want to buy 10,650 kilograms of apples per day. So we have a third point on our market demand curve. And we can keep going, asking the question, given the price, how many apples in total do people wish to buy? We would get more points, and if we did so, we'd be able to join them up and draw the market demand curve, and I'll draw it through the points that we have here. So this blue downward sloping line is our market demand curve for apples. It tells us, for any price of apples, how many apples buyers would like to buy in total. Similarly, the individual supply curve tells us the plans of an individual seller of apples, and the market supply curve tells us the aggregate plans of all apple sellers in the market. So we're going to need a market supply curve to work out our equilibrium. So let's suppose if the price is $4 a kilogram of apples, apple sellers in total would like to sell 7,300 kilograms of apples per day. At a price of $6 per kilogram, they would like to sell 9,500 kilograms of apples per day. And at a price of $9 per kilogram, they would like to sell 11,900 kilograms of apples per day. We have 3 points on our market supply curve, and we can join up those 3 points. If we do so, we would get an upward sloping curve that shows, given the price, how many apples in total suppliers would like to sell. So our blue upward sloping line is our market supply curve for apples. At any price, it tells us, given the price, how many apples in total suppliers would like to sell. So now let's put our demand and supply curves together. We have the downward sloping blue demand curve, we have the upward sloping black supply curve. The supply curve is our plans for sellers, our demand curve is our plans for buyers. There is only one point on this diagram where both the plans of buyers and the plans of sellers can be satisfied. There is only one point that can be our equilibrium price and quantity. And that is the point here, where the demand and the supply curves cross, where the price of $6, sellers would like to sell 9,500 kilograms of apples, and at the price of $6, buyers would like to buy 9,500 kilograms of apples. The plans of sellers in total are the same as the plans in buyers. They can carry out their plans and be satisfied. So our equilibrium price, what we'll sometimes call P star, is $6 per kilogram for apples, and our equilibrium quantity, what we sometimes call Q star, is 9,500 kilograms of apples per day. Your reaction to this should be, so what? What have we actually done? We've defined an equilibrium as being a situation where everyone can do what they would like to do given their options and constraints. But that still doesn't tell us why the equilibrium price and quantity are good predictors of what will actually happen in the market. But in fact they are extremely good predictors given our dynamic assumptions. To see this, let's pick a price other than our equilibrium price of $6. For example, let's pick a price of $9 up here. Remember that at that price of $9, buyers only want to buy 7,000 kilograms of apples per day, but sellers would like to sell 11,900 kilograms of apples per day. So the quantity that sellers would like to sell is significantly greater, 4,900 kilograms of apples greater than the quantity that buyers would like to buy. We call this gap the difference between the 11,900 kilograms that sellers would like to sell and the 7,000 kilograms that buyers would like to buy, excess supply. And if you remember, our dynamic assumption is that when the amount sellers want to sell at a given price is more than the amount that buyers want to buy at that same price, then we would expect the price to start to fall. And indeed, that will happen at any price above our equilibrium price of $6 per kilogram. At any higher price than $6 per kilogram for apples, you will have a situation of excess supply, and by our dynamic assumption, you will expect the price to fall. So, if the price is above the equilibrium price, then the quantity that producers would like to sell exceeds the quantity that buyers would like to buy. There is an excess supply for apples, and we expect the price to fall. But what happens if the price is below our equilibrium price of $6? Well, let's pick a price of, say, $4 per kilogram for apples. At a price of $4 per kilogram, sellers only want to sell 7,300 kilograms of apples. Buyers would like to buy 10,650 kilograms of apples, but you can't buy apples if no one's willing to sell them to you. So we're going to have a situation of excess demand. The excess demand will be given by the difference between the amount that buyers would like to buy and the amount that sellers want to sell at that price of $4 per kilogram. And because there is excess demand, because the amount buyers want to buy is more than the amount that sellers would like to sell, we expect the price to start to rise by our dynamic assumptions. And in fact, that holds for any price below the equilibrium price. At any price below the equilibrium price, there will be excess demand, and we expect the price to start to rise. So if the price is below the equilibrium price, then the quantity that producers would like to sell is less than the quantity that consumers would like to buy. There's an excess demand for apples, and we expect the price to rise. Notice what happens. A price above that equilibrium price of P-star, or $6 per kilogram for apples, excess supply, price falls. A price below that equilibrium price of P-star, or $6 per kilogram for apples, at a lower price, excess demand, and the price rises. By our dynamic assumptions, the price is going to move in the market to the equilibrium price, that price where demand and supply cross, that price where both sellers and buyers' plans can be satisfied. So our equilibrium price is a great predictor of what the market price will be when our assumptions are satisfied, when our assumptions are realistic. So to summarise, our equilibrium price, where market demand intersects market supply, is our predictor for what the market price will be. It's our predictor for what buyers will pay and sellers will receive in the market. Why? Well, if there's a higher price, we expect excess supply and the price to fall. If there's a lower price, we have excess demand and we expect the price to rise. So the equilibrium price is a good predictor of the actual market price when our assumptions are satisfied, when they're reasonable, for price-taking consumers, for price-taking producers, and when our dynamic assumptions are satisfied, the equilibrium price will be a great predictor of the actual market price. Thanks for listening. Talk to you next time.